do like one from each section? Would that be good?
Yeah.
Okay. Well, we are learning, so good question. So we are learning a new lesson today. That was the one we let go of before Christmas break. But then we'll review for 2 days and then we'll have a quiz on this chapter. It's only been like 3 or 4 sections. And then we'll have 2 days to review for our exams. So we will be quizzing testing on Thursday. So, because that's not my handwriting.
No, it's small.
No, I thought, why did they?
Because they're
Weird.
So, should we pick one from section 9.3 to do? 4.
Number 1, good call.
8.
Number 5.
Spin a wheel.
I might pick the one that I think is the best.
Are they not? Cool. Oh, yeah.
Oh, just checking.
Keep checking. My battle scars.
No, stop. No, shut up.
I would say 8 or 10.
What?
Okay.
I have this like skin rash from work I have to go to the doctor for. It's from work, I have to go to the doctor for it.
Want to smoke?
Where did you get
No,
those?
Yeah. Like the sanitize solution. I think I'm like allergic to something yet.
That's what you get.
So she wears that, and she purposely wears the same thing, but her hands pop up. So it breaks through the gloves sometimes, so sometimes she's like,
Everything but
and then like by the end of the shift,
Just
there's
put
like
drink on your-
tabs all
Oh,
because those ones are like the like half fuzzy ones, and so
Yeah, I didn't drink before.
they don't like stay on enough.
But she sounds so hard to work with Gary.
It's fun for special orders.
What happened?
I feel so bad. She's like the nice old lady coworker.
Okay. So, on this one, you guys, number 8, you have to do some factoring before you can do any kind of canceling. So just a reminder with this section, which again, it probably feels like a long time ago because it kind of was. We need to factor first. Yep. Yeah. We need to factor first so that we can make sure we can cancel things because we can't cancel them right now. So this x squared minus 4 is a difference of squares. So it's x times x, multiply to get negative 4, but add to get 0. So plus 2 minus 2. So this is the kind of factoring we had done a little while ago. This over here can't be factored. This is kind of good review going into the exam with factoring. Then this 4x squared minus 1 is another difference of squares. 4x squared is 2x times 2x. 1 is 1 times 1, it's just the positive and negative. And now if you look, there's the same thing on the top and the bottom. So then we're just left with x minus 2 over 2x plus 1. Now you can't cancel anymore again because of the plus and minuses that are there. All right? Hopefully, if you guys are comfortable with ones like that, you're probably pretty good with that section 9.3. Then 9.4 was the adding and subtracting. Let's do number 7 if that's okay for 9.4.
Yeah.
Okay.
I mean, we can't really stop you.
Whose spot is this?
He just got his left spot.
What?
Okay. Okay, guys. So We need to add these two together for number 11, but right now the denominators aren't the same. So I need to first factor them and tell if I can get them to be the same. So in this case, they're each able to be factored. So I can take an x out here, and I'm left with x minus 1. Out of this one, I can take out an x, and I'm left with x plus 1. So they're pretty similar, but different enough that we have to do some things to make them the same. So this one already has an x, and so does that one. This one has an x minus 1. This one has an x plus 1. So that means this one needs the x plus 1. And this one needs the x minus 1. If the bottom gets it, then the top gets it as well. Now the bottoms are the same. So the bottom has now become x, x minus 1, x plus 1. They're all the same across the bottom. But on the top, we're left with x plus x, which is 2x. And we're left with 1 plus a negative 1, so 1 minus 1, so just 0. So at this point, when I want to simplify this, since this x is being multiplied, I can cancel it with this one that's being multiplied. So I'm just left with the 2 on top, and then these 2 on the bottom. Oops, not 2. So the adding and subtracting, a lot of times in order to get that common denominator, you might have to factor first. And then in section 9.5, how about number 10? I'm kind of just trying to pick one that I consider to be one that's doable, but also maybe tough. So.
Good one.
Yeah, I just told you not to say good.
I know, I said free one.
Okay, so if you guys recall, we want to figure out what all the common denominators are so we can use that to cancel these. So I'm going to factor this in order to figure out what the common denominator is. So this is going to be multiply to get negative 8, add to get 2. So plus 4 minus 2. Alright, and I left a bunch of space because I know stuff's going to get multiplied. So our common denominator is this, because those two have that. So that's what I'm going to multiply all these tops by. So all the tops are getting multiplied by that common denominator. So over here, they get to cancel. We'll just be left with 3x. Here, the x minus 2's will cancel. We'll just have 1 times x plus 4, so it'll just be x plus 4. And then here, the x plus 4's will cancel, and I'll be left with x times x plus 2, or x minus 2. This one might be tougher than I guess I thought. Maybe because there's factoring and stuff
And
going
she
on here.
gets stumped by her own problem. Oh yeah.
Okay, so let's see here. I'm going to move everything over to one side. So I'm going to bring this 3x over. So I have x squared. I have a negative 5 plus 1, so negative 4x plus 4. Oh, no, it's not. How does that work? 2 and 2? Yeah. Okay. So I go to solve this and I get x equals 2. I guess it's not as bad as I thought. But the issue is if I put 2 back into the denominator up here, remember we have to check those solutions, x minus 2, 2 minus 2 would give us 0 in the denominator. So this answer gets thrown out and be considered an extraneous solution because of the fact that it doesn't work in that fraction. So that one answer we found ends up being a no solution. All right. So
74 different base AP languages
oh my gosh.
Okay.
How many more days?
74.
So do you have it, give it like this quarter and the next quarter?
Yeah. We had to have it in like the morning.
Can't take one for
Okay. So I'll let you guys know right now. The reason this looks so long is mostly because of the graph paper. The last example we're not really going to do. I'm going to show you that, but then we're not really going to use that. So just a heads up. So really it's just the kind of the one page of notes here. So the graphs are just on there ready for you.
2021. I did it. I wrote 2 hands.
Yeah.
When we went ramble on Jesse's
I was writing bills, or I was doing like writing checks for bills the other night, and I wrote all the dates wrong. So
So you had to rewrite all the checks?
I didn't because I already had them sealed in the envelope. I'm thinking they can just maybe like put a little 2-1 on behind my 20. I'm hoping, or the check will be invalid and my bills will all be late. So I did not fix this. Okay. So, we talked previously about excluded values. And excluded values are values that don't work for the problem. Kind of like that last example we did, or the last homework question we did, where 2 didn't work in the problem because we can't have the denominator equal 0. So, like in these cases, there's some excluded values. And these are just the functions. They're called the G function, the R function, just another notation for that. So remember, so when they talk about the excluded values, is we don't want the denominator to equal 0. So our denominator can't equal 0. So we have to figure out what values where the denominator can't equal 0. Because that's going to help us today what we're doing for our graphs. So we're graphing these today. So what would make this denominator equal 0? 2. Yeah. And you might do that without even having to do any work. So x cannot be 2. That would be considered an excluded value. Now, that's a really weird thing to graph. So if I say x can't equal 2, that means the graph can't have a point at 2. So in terms of a graph, it kind of ends up doing something kind of weird at 2. And I'll show you guys that today. It even has a weird name. So we'll talk about that in a little bit. So when we're talking about graphs and these excluded values, again, kind of some weird things happen there. Now this next one, to make this equal 0, you can do this a couple of different ways. You can either factor it or solve it by square roots. What do you guys want to do here? Do you know how to factor that, or do you want to solve it by square root? I don't hear people screaming, let's factor, so we'll go this way. Square root of 1 is 1 and negative 1, plus or minus 1. So these are the values that x couldn't be, is 1 and negative 1. Now again, these excluded values on a graph is where kind of like when you ever played with someone's like graphing calculator and you're like, oh, I did all these crazy things in this graph. I made up this really crazy graph. I feel like everyone does that the first time they play with a graphing calculator, or I did, and I'm a math dork, so that's. But it probably has something to do with this. So I will actually, maybe I'll actually pull up the graph real quick and show you guys. Not slope, dude. It's not that exciting. This would be slope, dude. I'm like, he's hallucinating or something.
Slope dude, more like smoke dude.
Stop. That was not funny. I'm laughing because that was so funny.
Gonna change my name to like nothing or something. Or Happy or like Rico. I know what you're for Rico.
What's up?
Sasha.
All we've done so far is the form. We just set the bottom equal to 0.
You better be lying.
No. I'm joking.
You did? Are you sure? Okay, guys. So I wanted to show you guys what this graph looks like. Guys, quiet please over there. I wanted to show you guys what this graph looks like in terms of why that excluded value is kind of so interesting on a graph. So where x equals 2 is like right around here. And so what happens is this graph, it's like running along, and all of a sudden it's like it's going to run into a fence. And so this line here, there's a vertical line, this x equals 2, where the graph can't touch it. It's kind of like a force field or a fence if you were a dog or something. And you had to turn and run away from it. So you like run along that fence. And then it starts back up again down here. So this graph, it never actually touches that line. It's called an asymptote. Sounds like, again, a strange word. It's kind of a strange thing that happens on our graph. Is the graph won't hit the graph or won't touch that spot. It'll run alongside of it. So that idea is kind of why we want to know about excluded values. So let me show you the other one. Let me show you the other one, because that one had 2 excluded values. So if you look at this one, this graph is kind of even crazier in that this one has 2 excluded values. So what we're trying to kind of picture is that there's these imaginary lines that run vertically. And so in this case, it's 1 and negative 1, where the graph is, it's kind of that barrier, that force field, or that fence that stops you from running like out of it. So you're running along, and then you see the fence, and you turn. Here, they like turn around and kind of stay within that fence, and then here they're over on that side. So those excluded values are super important for our graphs, and we're going to figure those out today and use them to graph our equations. So
Can you make them like a smiley face or something?
make a smiley face. I'm sure there's a way. I'd have to think a little bit longer. So not quite as easy as maybe we'd like. You can do that for extra credit, Kinsey.
Okay.
Like she needs it.
Okay. There's the door.
I'll show you it. I can probably show you one in a little bit. I can think of one. But okay. we're talking about rational functions again today, so fractions as our functions. And so, again, the denominator, it says g of x can't equal 0. G of x can't equal 0. So we can't have that value equal 0. So what we get is we get these asymptotes. Sounds like I'm kind of about to swear and then I don't.
Oh.
I know. It's an asymptote. It's a line. So let me define asymptotes up here and then we'll talk about those specifically. Well, okay, that's fine.
Where you going?
Why do you care?
Yeah.
So the asymptote is a line where the graph is not defined. So we don't have an answer for the graph at that point. So what we then get is these vertical and horizontal asymptotes. And I'm trying, I need to find my notes real quick, sorry. Just want to make sure I describe it as well as I. So our vertical asymptotes is the vertical line that's kind of that force field, and it's always found from the excluded values. So the vertical asymptotes are found by setting the denominator equal to 0. So those are those excluded values. Now there can be a horizontal asymptote, which goes this way then, obviously. This one depends on the type of function. So this one doesn't always work the same way. So this one will depend on the type of function. And I'll show you guys the difference. Now these graphs today are going to be sketches. So they're not going to be perfect. I'm not going to like expect you to have the most perfect graphs ever. But I do want you guys to kind of put some main points on those graphs. So the x and y intercepts are two of those points. Guys, I really need you to be listening. So those of you guys with your computers open, not right now. So the x and y intercepts are some of the points that are really easy to find. So what do we know about x intercepts? What do you guys know about x-intercepts? They're on the x-axis, so they're points on the x-axis. What do you know about those points?
Say it louder, Kinsey.
Yeah.
The y is 0.
The y equals 0, very good. So we like those points. So we're going to set y equal to 0 and find those points. So we're going to set the function equal to 0. And essentially, we're going to get that from setting the top of the equation equal to 0. And then the y-intercepts are points on the y-axis, so that's just where x equals 0. So we're going to get into our graphs here. And I'll show you guys the different types we will have. Okay, so let me explain the difference between these types. So off of here, so there's like some weird words kind of hidden in there. But so the first type of asymptote, horizontal asymptote, is coming from, it says if the degree of the numerator is equal to the degree of the denominator. So that's the power on each of the variables, if that's equal. So the degrees are equal. And so that's the power on the exponents, or the power on the variable. The degrees are equal. Then what we do is we just look at the coefficients. So if the degrees are equal, you're going to look at the coefficients for our horizontal asymptotes. So the coefficients are the numbers in front of the variable. So what I'm going to do then is just going to be y equals, going to be our equation. Look at the coefficients. The top one is the coefficient. 2. What's the bottom one? 1. So the horizontal asymptote is going to be 2 over 1 or just 2. Y equals 2. So that's going to be our dividing line or our fence or our force field the flat way. So this is the coefficients. So at y equals 2, I'm going to kind of put a line here as kind of our barrier. And I'm going to use like a highlighter pen just so it's clear. So this isn't actually part of the, oh gosh, that was a great choice. So this is my horizontal asymptote. And so this one is just kind of a dividing line. This is like that force field or our fence. The vertical asymptote, if you guys recall from the page before, we said that comes from setting the bottom equal to 0, because that's basically the excluded values. So the vertical asymptote comes from setting the bottom equal to 0. So x minus 1 equals 0. So x equals 1. So that's going to be my vertical asymptote. So that's going to be my vertical dividing line. So x equals 1. So we basically have a set of 2 fences and basically like 4 quadrants. We have to figure out where our points are going to show up in those quadrants. So a great thing to do is use the intercepts to help us with that. Because the intercepts are easy points, or they should be. The x-intercept is where y equals 0. So essentially this is where we have the top equaling 0. And you guys are going to want to take good notes on this because this is all kind of hard to remember, obviously, like if you haven't seen it before. Sorry about this weird homework thing. I don't know why that's showing up there.
Rational.
I must have cut and pasted too much.
Rational.
So the top equals 0. So we're going to set 2x plus 6 equal to 0. So I got points at negative 3, 0. So that gives me one of my points, but this is good. This tells me where the dog is running in the yard or where the person is stuck in that force field. So negative 3, 0, that means for negative 3, I'm going to have to be in this little quadrant here. Now, I want to get a kind of a better idea of what the graph looks like, so I'm also going to check the x-intercept. The x-intercept is where x equals 0. Or the y-intercept, sorry, thank you. And what that is, it's putting 0 in for each of the x's. So this will be 6 over negative 1. So 0, negative 6. And so if I'm on that blue dot and I want to run to the left, I'm going to run, but then I'm going to run into the fence, so I have to run along it. If I'm going to run to the right, I'm running, and I'm going to hit that fence, so I have to run along it. So it's kind of, you're just kind of this stuck in a cage, running one way or the other. So I have half of the graph done at this point. I know on this side of the graph is all below this yellow dotted line. Because if I pick any points above here, I know it has to stay below that line because of that idea of that asymptote. So now I need to figure out what's going on this side. So I'm going to have to pick a few points just to know what's happening. Is it above or below that asymptote before I draw the rest of my graph? So I'm going to pick a few just chosen points. Any suggestion on a, oh goodness. Any suggestion on a point we should choose?
0, 2.
Well, okay, we only want to pick half of it though. I want to substitute a number in, so what point? 2, so like x equals 2. Because 2 is on this side of the purple line, because, okay, so this side of the purple line, we know what's going on over there. This side of the purple line, we want to figure out what's happening. So Ethan suggested picking x equals 2. We're going to put that into our equation to see what it is so we know where we're at in this next part of the graph. So we're going to put the 2 into this equation up there. So 2 times 2 plus 6 over 2 minus 1. So I believe we get 10. So 2, 10 is another point. So 2, 10, we're way up here. But that tells us already that's the section we'd be running in then. We wouldn't be down here. So I know now that my graph is going to kind of slope this way. And this is a spot where once you have the point, I'm fine with you kind of just sketching this. If you're really like, that drives you crazy and you want to pick another point, like you want to check what 4 is, you check 4. This is 8 plus 3 is, or 8 plus 6 is 14. Well, it should be 4 minus 1 over 3. So like 4-ish. So 4-ish, if you want to know about where it is. But it would do the same thing because of the way those asymptotes behave. So we know we're going to be on either side of those asymptotes there. So I don't need a perfect graph, I need a sketch. So it doesn't have to be perfect. If you want to pick more points, you can and kind of see what happens. But like my answer keys are probably going to have a lot more points maybe than yours are. But I would say a point in each part of the graph. And I'll be kind of looking for work like this, that you showed me that you did that. So this is the first type of problem. And we're learning, there's 3 total. However, we're not doing the last one. The last one's really tough. So we won't worry about that one. So the first one we did so far here was the degrees were equal. And that was the power on the variable was equal. So the next one, we're going to do when the degrees aren't equal. Do we need a break before that?
Yes.
Okay. I don't think we can go outside. A little chilly.
It's 27, 26, sorry.
So